All right, like I said earlier, this is almost like pre-algebra. Maybe not towards the end, but it's no more than Algebra 1, to tell you the truth. So this is just a quick little review. We'll go through the first part pretty easy. Um, let's talk about the answers to each of these operations. When we talk about an operation, what are we talking about when we talk about math operations? We're talking about addition. We're talking about what? Subtraction. You're talking about multiplication. And then what? Division. All right? So what do we call the answers to these things? Okay, if I had the answer to an addition problem, what do we call that? The sum. Very good, right? You learned this way back in the day. Subtraction, what do we call that? Starts with a D. Difference. Okay, the difference between two numbers means you subtract them. What about the answer to a multiplication problem? The product. Good. We'll be using these words from time to time, so that's why they're putting them down. I guess they don't want to assume that you already know this stuff, but you should probably already. And what's the answer to a division problem? It's probably a word you don't use near as much as you use the other ones. It starts with a Q. A quotient. Very good. So those are the answers to those problems. All right. Let's talk about exponents, because we'll be doing stuff with exponents. I'll just shorten it a little bit. Exponents. So like, I don't know, x to the third. Okay, x would be considered the what of this? The base. Good. So that would be the base, and then the little 3 on top there, what is that? That's the actual exponent. I'll write the whole word out. Okay? Here's another thing that we're going to see quite a bit of from time to time. That's when, we'll just write it like this. It's the absolute value. Remember doing absolute value? What does that symbol look like? There's a symbol for it. What's the symbol? Yeah, just 2 lines, and let's put something in it like an X. Yeah, let's talk about absolute value right now. So let's put a number in. So what if I said, what is the absolute value of 3? What is that? What is it? 3, just positive 3. So what does the absolute value do? It doesn't necessarily just change the sign of the number. A lot of people think that, okay? They go through years thinking the absolute value changes the sign. It does in one case, when what? When it's a negative, right? But the absolute value is just keeps everything positive. What it is this. What it is all right, so here's a number line, here's 0. The absolute value basically means how far away from 0 is something. So when I measure a distance, if I say how far something is from something else, like if I said measure the length of this room, I gave you that meter stick wherever that is now, and I've given you the meter stick and I said measure it, would you say, oh, it's about negative 15 feet? Would you go negative? No, you would never say negative, would you? You would just say 15 feet. It doesn't matter if you measured it from that wall to this wall or from this wall to that wall. It's still 15. Would you agree? Whatever the distance is, it's probably longer than that, but you get the idea. So that's what absolute value means. So if I had a number over here at 5, what's the same distance on the other side of 0 as 5 is from this? It's negative 5. Very good. So what is the distance between here and here? It's just 5, right? Whatever we measure it in. We could measure it in inches, centimeters, meters, feet, whatever, okay? So that's 5, and that's 5 right there. So if I had the absolute value of negative 5, what does that mean? It means how far is it from 0? And it's just 5, all right? We measure things positively. We don't measure things negatively, all right? Everybody good with absolute value? All right. Okay, again, here's where we're doing some pre-algebra stuff. I'm going to give you some rules. And the first rule is for addition. I'm going to go through this quick because I think most of you will be able to just look at an addition problem with certain signs and just be able to figure it out on your own without even thinking about these rules. All right, hold on. Put my phone back. All right, so here we go. So we got basically two rules for addition. We have one rule when you're adding two numbers, and you have the same sign. I'm not going to write all this out. I'll just give you an example for each. And then you have a rule if they're different signs. Different signs. All right, so let's add two numbers together with the same sign. So let's add a 3 and a 5. Make it super easy. They're both positive, correct? So the rule for the same sign is you add the numbers up and you keep the sign of what each of the numbers are. If they have the same sign, they got the same sign. All right, I don't know where I was going with that. But that's positive, that's positive. You just add the numbers and keep the sign. All right, if you want to write that down as a rule, if you want to remember it, add the numbers, keep the sign. So I just add them up, that's 8. They're both positive, so my answer is 8. So what if you had -3 plus -5? Again, they're the same signs. They're both negative, right? So what's the rule? Add them up and keep the sign. So add them up, that's 8, but we keep the sign. What's the sign for both of those? Negative, so that's a -8. So it's coming back to you. Maybe the summer has clouded your mind a little bit. Maybe you forgot how to do some of that stuff. But I would say almost everybody, if not everyone in here, probably already remembers that. What about different signs? What if I had 5 plus -3? That's right, it's positive 2. And you didn't even have to think about the rule, did you? You looked at it and you're like, yeah, I know what that is. And you're probably at that point right now. But this is in the book, so we're going to hit it. So what is the rule for different signs? The rule for different signs says if you're adding two numbers and they're different signs, one's positive, one's negative, you actually subtract the two numbers and you keep the sign of which one? The larger one. The larger one, okay? So 5 and 3. 5's bigger than 3, okay? And so you subtract the two numbers. 5 minus 3 is what? 2. You keep the sign of the bigger number. 5 is bigger than 3. It's positive, so my answer is positive. What if you did it the other way around? What if you did 3 plus -5? Again, different signs. What's the rule? Subtract the two numbers. Forgetting the sign, just subtract the two numbers, 5 and 3. What's 5 minus 3? It's 2. But what's the bigger number? 5 is, right? And some people might say, well, Mr. Hamrick, -5 is bigger than 3. But again, forget the signs for a second. What's bigger, 5 or 3? 5 is. It's negative, so what's my answer? It's negative. Okay? I don't want to spend any more time on that because I think you guys knew that already. There's a rule for subtraction. And basically, there's really only, as far as I'm concerned, there's only one rule for subtraction. Here's what I say. Now, there's a cute little way when you're in middle school, your teachers usually teach you this way, but here's what I say. I don't like all these cute little sayings. I like real short, simplified sayings. And I always say, here's what I say, subtraction, you add the opposite. To me, that's pretty easy to understand. Now, there's a little cute little saying you learned in middle school. What was that about subtracting? Do you remember? Add a line, change the sign, right? A lot of people like that because it rhymes and it's cute and all that kind of stuff. Mine's kind of just straightforward and boring. Add the opposite, all right? But then you got these women teachers always change, add a line, change the sign. Oh, it sounds so cute, right? But people remember it, so I'm okay with it, okay? I'm not against that. But if you want to add a line, change the sign, that's fine. What does that mean? So watch, 5 minus 3 is a subtraction, correct? So what I say add the opposite. So you take that minus, you just make it a plus, right? That's the add. And then you take the opposite sign of 3. What's the opposite sign of 3? -3. And now we can apply the rules of addition. So really, I don't really have a lot of rules for subtraction. I always change it to an addition problem, and then you just apply the rules of addition. Does that make sense? So what does the rule say? Add the opposite. Now, I'm adding, I got different signs, so I subtract the two numbers, keep the sign of the bigger one, and it's 2. And you're like, well, Mr. Hamrick, I already knew that 5 minus 3 was 2. Yeah, I get that, but what about this one? When you're first learning how to do this stuff, this next part messes people up. What if you had 3 minus 5? So if you talk to a 4th grader, maybe a 5th grader, and you said, what's 3 take away 5? That's probably how they talk in 4th and 5th grade. Who knows? It's been forever since I've been in 5th grade. I can't remember. But that's how I would assume that they would say it. 3 take away 5 or 3 minus 5. You're like, well, if I got 3 things and I take 5 things away, how can you do that? That's impossible. Well, we do have negative numbers, right? So you talk about money. If I have $3 and somebody comes up, right, and they're like, Mr. Hamrick, you got to pay me $5. I'm like, I only got 3. Well, what does that mean? That means I owe him $2, right? So I'm $2 in the hole, in the negative. Does that make sense? Yeah? So that's why we have negative numbers. All right, so 3 minus 5. So what's the rule? Add the what? Add the opposite. And now it's an addition problem. Now I can use these signs. They're different signs. So that means I do what? Subtract, take the sign of the bigger. Okay, so I subtract those 2 numbers, I get a 2. Take the sign of the larger number, which is negative, and I get a negative 2. It's coming back to us? Yeah, you're probably thinking, well, it never left me. Well, that's good. I'm glad. You could say add a line, change the sign. That's fine. But I just like to say add the opposite. All right, let's keep going. That was addition and subtraction. What do you think is next? Multiplication. Very good. So let's do multiplication. And actually, division has the same exact rules. So I'm going to put multiplication and division. All right. Again, we have rules for same sign and different signs. Did I do that underneath before?
Any 6th or 7th graders who ordered lunch, please go down to the amphitheater to pick it up, please.
All right, so if you have the same sign, this is kind of easy. If I'm multiplying or dividing and I get the same sign, the answer is always what? Okay, thank you. I got one person participating. It's always positive, right? If I multiply two positives, I get a positive. If I multiply 2 negatives, I get a what? No? No? Positive. Okay, here, let me write it down. So if I have the same signs, the answer is always positive. Okay? Let me give you an example. 3 times 5. They're both positive, right? So they're the same signs. So you multiply them together, you get 15. What's the sign going to be? Just positive. Okay, we didn't have to have any help with that. You knew that from like 2nd grade, 3rd grade, something like that. All right? But here's where people get a little confused. What if they're both negative? Again, same signs. If they're both negative, your answer still is going to be what? Positive 15. You remember that one? All right. So when they're the same signs, the answer is always positive. So what do you think if you have different signs? The answer is always, here, I'm not going to write all that out. The answer is always what? Negative. All right. Doesn't matter which one's bigger, which one's smaller. Doesn't make a difference with multiplication and division. Your answer is always negative when they're different signs. So let's use these same numbers again. Let's go negative 3 times positive 5. So you got different signs, right? Multiply them together, you get 15. If you got different signs, your answer is always what? Negative. So negative 3 times positive 5 is negative 15. And then what if we did this? 3 times negative 5. Does it matter which one's bigger, which one's smaller for multiplication? Doesn't make any difference. You still get negative 15. All right. And the same thing with division. Let's do some division. What if I had 12 divided by 3? What's 12? That's people look at this like, Mr. Hamrick, that's a fraction. That's not division. But it is a division, isn't it? Right. So it's 12 divided by 3. And most of the time in algebra, we're getting away from this. Remember when you were a kid, you did that for a division sign? Okay, when you start getting into algebra, you get, that goes away. It's a weird looking 3, but that's supposed to be a 3. All right? So this is what we do more in algebra. We write it as a fraction. This means 12 divided by 3, which is positive 4. It's positive 12, positive 3, same signs, always what? Positive. What if it was negative 12 divided by negative 3? Does that change the answer? Nope, because they're both the same sign, their answer is always positive. But if you have negative 12 divided by positive 3, what's that answer? That's negative 4. Does it matter that that one's the big one? No, it doesn't make any difference. So if I go 12 divided by negative 3, that's what? It's also negative 4. Okay? Let me talk about one more thing with a fraction. So what if I had some weird fraction like 3/7? Okay? What if I had negative 3 divided by 7? What's my answer? It's always what? Negative, correct? So there's 3 different ways I could write a negative fraction. I could put the negative on top, or I could put the negative on the bottom. Would that make any difference at all? No, because it's still negative, right? Or I could put the negative right in the middle. Okay? A lot of people get confused on this. I can put the negative right in the middle, and that's still negative 3/7. All 3 of those are exactly the same thing. So let's make sure we get that straight, because there will be time later on where we get more complicated stuff. We're going to have variables, we're going to have exponents, we're going to have all kinds of stuff like that. And for some reason, some people don't realize that putting the negative in the middle is the same thing as having the negative on the top or the negative on the bottom. But most of the time, we will write it like this. Put the negative right out front in the middle. Okay? Most of the time. Not all the time, but most of the time. We good? All right. We're rolling right along, aren't we?
Mr. Hammer, excuse the interruption. Can you send Jocelyn down for an early dismissal, please?
Okie doke.
Okay, thank you.
All right. So just watch the video for the end of it, because it starts getting a little bit more complicated. Not a whole lot. It's almost embarrassing teaching this stuff in an Algebra 2 class, isn't it? Don't you want to, see, when I write, don't you want to learn harder stuff than this? Probably.
Teachers, just an announcement for the 11:30 to 1 picnic. Teachers, and students, you're going to go straight outside to the outside the TC lobby. You're going to start getting your chairs and blankets. You can start eating. We're going to call grades down shortly. 8th graders can now go to the NPR to pick up your lunch.
Well, if you're old like me, you can get down to the ground. Getting back up, it's a different story.
Where would I put my chairs?
I don't know. I would guess most people are not going to have a chair for today. All right, let's do order of operations. We have all seen this a million times. We're going to see it 1,000,001 now. Here we go. Everybody with me? All right, this is what I feared for this being so easy that people figure they can just talk and not deal with this. We got a little thing. It's a little mnemonic device, I guess. You ever hear that word? Mnemonic. It's not demonic. That's quite different. Mnemonic, but it actually is spelled with an M. Mnemonic device. You know what that means? Oh, I didn't spell that right. Mnemonic. There we go. It's a mnemonic device. It's like you learn different things by knowing what the first letters stand for, right? And it makes a word, like the FOIL method. Remember FOIL method? Okay, in Algebra 1. That's a mnemonic device. This is too. It doesn't really make a real word, but a lot of times we say PEMDAS. You ever hear that? Or I used to teach it, please excuse, do you remember this one? Please excuse my dear Aunt Sally. All right? Doesn't really stand for that. It's just an easy way to remember what order that you do operations. What is the parenthesis? Well, I gave it away. My goodness. I was thinking of the answer. What does the P stand for? Thank you. Parentheses. What is the E? Exponents, and then multiplication, division, addition, and subtraction. Now, the multiplication and division, they kind of go together. You kind of do those in the same step. And then the addition and subtraction, you do that in the same step. All right, so they kind of are grouped together, and those are grouped together. You ever see this on social media? They got memes all the time. And they put this, okay, what's the answer? And then you got thousands of people commenting, and you got all these different answers. Anybody see that on their social? I mean, I'm only on Facebook. So I'm an old man, so I'm on Facebook. I bet you they do that on Instagram, though, too, don't they? Do they have those memes on Instagram? I would think they would. I don't ever get on there, but I actually have an Instagram account, but I've never posted one time on it. I don't even look at it. But anyway, that's what this is. So if you know how to do this stuff, you can be Mr. Smarty Pants or Miss Smarty Pants, right? And get on Instagram or whatever, Facebook, and then put in the right answer if you know order of operations. That's why people mess it up. All right, let's do an example. All right, this is technically example 2 for this lesson. And they got A, B, and C. All right, so let's do A. Start off super easy. 2 plus 4 times 3. All right, what do we do? 2 plus 4 is 6, right? 6 times 3 is 18. Is that my answer? Wrong. All right, you don't do the 2 plus 4 first. What do you do first? You do multiplication before you do any addition. So what's being multiplied? These two right there. So you have to do that first. Okay, so this is 2 plus what? 12, and that is 14. Everybody with me? All right, so make sure you do it right. I mean, this is just the way that people agreed a long time ago on how to do these problems. People say, well, why can't you just do 2 plus 4? I like to do that better. Well, because people agreed long time ago that this is how we're going to do it. Okay, we got to all have the same set of rules that we're abiding by. All right. When's this class over? 25, is that what it is? Oh my, I'm running short on time. All right, let's do part B. I don't know if we'll finish today, but I guess it wouldn't be the worst thing in the world. I don't think that. Do I have any more pages? Oh no, oh no, I got a whole nother page. Oh, I got a whole page and a half. Yeah, there's no way in the world we're finishing today, but we'll get this done and then we'll be finished. This order of operations stuff. Plus 1. This one's definitely a little bit more involved. Oh my gosh, everybody's interrupting my class.
6th, 7th, and 8th grade, if you have your lunches, you may now make your way outside in front of the Pusey Center and you can eat your lunch. Out there, teachers please accompany them outside.
Okay, here we go. So we're going to evaluate. This is probably what they would say, or maybe simplify. I'm not sure. I didn't write it down in my notes. Anybody have their book open? Does it say simplify? It might say simplify. Sometimes they'll say evaluate, sometimes simplify. It means basically the same thing. So what do we do here? Well, we got to go order of operations. So I see parentheses. See the parentheses? That's the first thing we do. All right? So let's do this. Let's go -2 squared plus, and then what's in the parentheses? -2, right? Remember how to subtract? Add the opposite? So that's a -2. But that -2 is being taken to the 4th power. I kept it in parentheses. It's super important, especially when that number is negative, that you keep it in parentheses. Right? -2 times, and then we do this parentheses. 4 minus 3 is 1. Everybody good? So we did all the parentheses. Now I do any multiplication. Well, actually, I go to exponents, don't I? Do I have any exponents here? Yeah, I got a couple here. So let's do those. Now look, this is -2 squared. You're not squaring the negative. What are you squaring here? Only the 2, and that's it. So that negative stays out in front. You just square the 2. 2 squared, 2 times 2 is 4. Now, this is a little different. You're not just squaring the 2 here. What are you doing here? You're squaring the whole entire -2. So it's -2 times -2 times -2 times -2, which is what? Positive 16. 2 times 2 times 2 times 2 is 16. So it's positive, so we put plus 16. And then you do this multiplication now. -2 times 1 is -2. Now we do any addition and subtraction. Doesn't matter which order. I could go 16 minus 2 first, or I could go -4 plus 16. Let's just go left to right. -4 plus 16 is what? 12. Minus 2 is 10, and there we go. Notice how I showed all my steps. If you have these problems in the homework, you need to show your work. Okay? Don't just say, well, I did this in my head, and here's the answer. I don't care if you could do this in your head. I don't care if you could do this in your head. I want to see that step right there. Okay? It's a big deal for me for you guys to show your work. All right? I will take points off on a quiz or a test even. I might give you the whole problem wrong. If all you do is just write down an answer and you could have shown the work, I might give you the whole problem wrong. All right? Because I need to see how you got the answer. Sometimes I'll write that. I'll put how, which means how did you get the answer? I need to see it. Everybody good with that? All right. We didn't finish it, but I will give you what the assignment is. So if you want to start on it and go to at least this point in your homework, then when I assign this for real, you won't have so much to do. All right, so it's section 1, 2. It's pages 10 and 11. And it's 1 to 35, just the odds. That makes it a lot better, doesn't it? Okay, just the odds. So, again, you don't have to go all the way to 35 because we haven't taught everything. If you can, if you already know how to do that, that's fine. Go ahead and go all the way to 35. Excuse me. All right, but you don't have to. We'll finish it up on Monday, then I'll officially sign it on Monday, okay?